Good day, everybody. How are you all? Today we are going to talk about a regression problem. So I'll share my computer screen with you. The following data show per capita income, which is an indication of economic development. So there are years from 1870 to 1960 and PCINC is per capita income. So the first thing is, what is the independent variable? So part A, make sure. Independent variable is year. Variable is year. X is year. And part B, dependent variable is Y, per capita income, PCINC as they call it. C, perform a linear regression between independent and dependent variables. So first thing you do is second button, then plus button on top of enter, then select number 4, you get clear all list and hit enter. Enter and you will get clear all list will be in your calculator screen, hit enter and then you get done. That means the memories have been cleared. So second plus 4, clear all list, enter, done. Then stat 1. So in L1, so next is stat and then 1. In L1, enter the years, which are 1870, 1880, 1890, then 1900, then 1910, then 1920, then 1930, then 1940, 1950, and 1960. So we are done entering the data in L1. Okay. Now we have to move the cursor to the first line in L2. So after entering data in L1, move the right cursor key, use the right cursor key. This is the right cursor key. To move the cursor to the first line in L2. Okay. First line in L2. Okay. So right cursor key, first line in L2, there you enter the PCINC, the Y values. So X in L1, Y in L2. So you start with 340, then 499, then 592, that's the 9, 592, then 757, then 927, then 1050, then 1170, 1344, 1826, and 2132. Once we have entered the data in L1 and L2, now we can do a plot, okay, a scatter plot to see how good the data is. So let me reduce this a further little bit and then use this key to move it. Okay. Okay. Now you can press part D. Here, zoom key. Where is the zoom key? Press zoom key. Third key in the top row. In top row. Zoom and then select number 9. Okay. And then press second y equal to. Now, before you do that, you have to do second y equal to. Okay. So let me erase this, just to be sure that. I have to erase this also. So after we have entered the data in L1 and L2, okay, then what we press, we spread second y equal to. Press so second y equal to. Second button and then y equal to. This is what you want to press. Second button and then y equal to is on top of it. Then select number 1. It should be, the first line should be on. So after you select number 1, it is plot 1 basically. So let me write it down. Plot 1. First line should be on. Cursor is on and flashing. Type will be the first type of chart, which is basically a scatter plot. And let me move this a little bit. My X list is L1. Type is the first type of chart you selected. The X list is L1. Y list should be L2. If it is not L2, you have to make it L2. How do you do that? You press the second button and then 2 to make it L2. Second button and then 2. So second y equal to number 1. Y list should be L2, second and 2. Okay. Now after we have made Y list as L2, you can press the zoom button and then number 9. Zoom and 9. And you will see a nice scatter plot like this. Let me draw the scatter plot that I'm seeing. See in my screen. The last 2 points are little outside the straight line. Seems like initially we have a linear plot, but then it may be exponentially growing. Okay, so this is your year in the horizontal axis and your PCINC on the vertical axis. Okay. So can you fit a straight line through this? Yeah. Except the first last 2 points a little bit off. Okay. So how do you fit a straight line through this? So let me. Okay. So now you're going to press the start button. So the start button. Then you highlight test on the top row. and scroll down to lin reg t-test. So tag, then highlight tests and scroll down to lin reg t-test, which is in the second screen. Okay, once you align the cursor with lin reg t-test, you hit enter. So X list is L1, Y list is L2, frequency is 1, and the fourth line is the alternate hypothesis, beta and rho, and you want to set it to not equal to 0. That's your alternate 0. And I'll explain in a minute what is rho. And rest you don't touch, and you go to calculate and hit enter. So beta is the slope in population, in the population. And rho, so this is beta. And then rho, this is Greek, capital R, is the correlation coefficient in the population. in the population. So you're doing the test. There's the significance of the correlation coefficient. That was one of the questions. Significance of the correlation coefficient. So that means you assume your null hypothesis is, we'll just do with the correlation coefficient, rho is equal to 0. And your alternate, which you have selected, is rho not equal to 0. Okay. So then you go to calculate, and hit enter. Remember this calculate, you hit enter after you go to calculate. Okay. And you will see. So I'll move this a little bit up. So first you'll get the regression equation. I'll change the color of the ink. So your regression equation is, let me write it out over here, y hat is equal to a minus 34380.048. That's your intercept, okay? Plus 18.5085x. So y hat, this is read as y hat, is the predicted PC per capita income. Okay. X, of course, is the years. And your slope is equal to 18.50, you may say 9. What does it mean? For every year, increase in every year, every 1 year, per capita income increases by 18 point, you might say 18.509, 18.51. Okay. Now we are going to test the significance of, okay. So I already wrote the null hypothesis and the alternate hypothesis. Again, if I create some more space here, okay. So my 80 is rho, population correlation coefficient. This is read as rho, Greek capital, Greek small r, population correlation coefficient is equal to 0. What does it mean? Status quo or null hypothesis, there is no relationship between x and y. There is no relationship between x and y in the population. No relation between x and y in the population. X and y in the population. Okay. And your alternate is rho. This is 8 sub A. Alternate is rho is not equal to 0. So we calculate a test statistic. So the test statistic is T. T is the test statistic which is in my calculator screen. So T, test statistic, is 11.736. What is a test statistic? You compare the calculated R to the hypothesized population correlation value of 0, correlation coefficient value of 0 in terms of value of 0 in terms of standard error. Okay, standard error. Standard, let me take care of that in terms of in terms of coefficient. So you're comparing the calculated R, calculated sample correlation coefficient to the hypothesized population correlation coefficient value of 0 in terms of the standard error. Okay. And look at the p-value. P-value is of course not 2.53. It is there's a E minus 6 at the end. What does it mean? That means P is equal to 0.000005 zeros and then 5, which is almost 0 actually. So we create some space. So compare. So what is P value? I should write that down. P value is the probability of obtaining a test statistic as extreme as in this case 11.736. Now compare P with alpha. Alpha, remember alpha is the level of significance that is given as 0.05. Is 0.05. P is less than alpha. Decision reject 80. Reject 80. Conclusion at alpha equal to 0.05. There is enough evidence to support HA. Enough evidence to support HA, which states rho not equal to 0. That means in the population, there is some correlation between X and Y. Okay. Now we have to find the residual. So let me move this again. We have to do a residual and a residual plot. Okay. Let me go back to this pen. So what is residual actually? Residual is y actual minus y hat, that is predicted y, from the least square regression line. So for each value of x in the table, in the early table given, at the beginning of the problem, at the beginning of the problem, there is a y actual also in the table, right? There is a y actual from the data. Now, if we plug or if we substitute the x value, the given x value in the regression equation, you will get y hat or predicted y for that x, predicted y value for that x. Now we have 10 data points, so it will be a lot of calculation, but we will have the calculator do the work for us. So how do you do that? And I will explain that in a minute. Okay, so steps with TI-84 to calculate residual value for each x, for each given x value. So first is on, then stat 1. Okay, so calculator. And it is preferable to have a TI-84 calculator. You first do stat, then 1, then move the cursor by right cursor key, move the cursor to the first line in L3, okay, and then use the up key, this key, up key, to move the cursor to where L3 is written. Okay. The next step. Press second key. And then stat key. Second key and then stat key, which is in the second row. Okay. And then scroll down to RESID, which is a short form of residual. And when you align to resid and then hit enter, when you align the cursor with resid you hit enter. So if you look at the bottom of your calculator screen, the right corner, you'll see L3 equal to L receipt. Okay. Now hit enter. Okay. And basically, so let me create some space. L3 is filled with residuals. L3 is filled with residuals values. Remember residual values, where residual is y actual minus y predicted. This is y predicted for each x value, for each x value. Now we want to make, now we want to make a chart of x versus residual. How do you do that? So x versus residual. So press second y equal to second. Let me write it down over here. Second, then y equal to button. Okay. And then select number one. Okay. First line should be on. Next line, type. You can go to the second chart, which is a line chart. This is a line chart. Second one. Okay. And the next line, X list is L1 is fine. Y list you have to change to L3 because your residual is in L3. How do you do that? Second button and then 3 button. Okay, so change the Y list. Change the type first to the second type of chart. Put the cursor on the second type of chart and hit enter. And then change the Y list to L3 by second and 3. Okay, and let me create some more space. And then press zoom and then 9. Okay, so zoom is in the first row of key, third key, and then 9. And the residual plot looks like this. The horizontal line is at where residual is 0. Residual equal to 0. Remember, these are your x values. Residual is on this side. These are the x values. So the curve you're getting, at least on my calculator screen, is something like this. So this is, we can conclude. Let me write it down. There is no particular pattern in the residual plot. Which is, remember, it is a plot of residual on y-axis, and x on horizontal axis, of course. horizontal axis. Some of the residual values are negative below the residual equal to 0 line. Some of the residual values are negative. Residual values are negative below the y equal to 0. This is the y equal to 0 line. This line are negative. So points which are below y equal to 0 line are negative, and some are positive. Some are positive. So ideally, let me get some more space. Ideally, we do not want to see any particular pattern in the residual plot. That means the least square regression line equation, the least square regression line equation is a good fit for the data, for the given data, for the given data. So I will stop here today. If you have any question, comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. And if you like this video, please share this with your friend. And you and your friends, please subscribe to my channel by hitting the red subscribe button. I'll come back next time with another interesting problem, interesting solution. Take care. Have a nice day. See you next time.